Imagine trying to spot a single firefly hovering right next to a blinding stadium light. The glare hits your eyes, washing out anything faint nearby. Out in space, astronomers face the exact same problem. When a massive asteroid approaches Earth from the direction of the sun, the intense solar glare completely overwhelms our telescopes. The rock's dim reflected light gets entirely swallowed up. To get around this, astronomers rely on a very brief period called the twilight window. By pointing their telescopes at the sky right before sunrise or just after sunset, they can use the Earth's own shadow to block out the worst of the sun's glare. But that small window means we have a massive blind spot in our own cosmic backyard. Large objects can cruise along, completely invisible to us, until the orbital geometry is just right. In September 2025, during one of those brief twilight sessions, astronomers spotted a faint dot moving across the sky. They nicknamed it Scooby, officially designated 2025 SC79. This map shows the paths of Earth and Venus, along with Scooby's rare trajectory. Scooby belongs to the Asteroids group, a small classification of asteroids whose orbits remain completely inside the orbit of Venus. It's incredibly fast, whipping around the sun every 128 days. At 2,300 feet across, a rock that size hitting Earth would trigger widespread destruction across an entire continent. The seismic shock would send magnitude 7.4 earthquakes rippling outward, leveling infrastructure hundreds of miles from the impact zone. A brutal wave of air pressure would race outward next, shattering windows and flattening forests. Then, millions of tons of pulverized rock and dust would shoot up into the atmosphere, creating a persistent haze that would block out sunlight and trigger sudden drops in global temperatures. Scooby isn't on a collision course with us. The fact that a rock capable of such extreme devastation could sit undetected in our solar system for so long proves how easily these threats can hide. To prevent a surprise impact, planetary defense relies on rigorous tracking. Inside facilities like NASA's Mission Control, an automated collision monitoring system called Sentry continuously scans the paths of over 40,000 known near-Earth asteroids. One of the most closely watched is Apophis, discovered in 2004 and named after the Egyptian god of darkness. Apophis is roughly 1,100 feet wide, making it slightly larger than the Empire State Building. You might think that tracking a rock in the vacuum of space is straightforward math, based on gravity and momentum, but predicting an asteroid's location decades in advance requires accounting for forces generated by the rock itself. This diagram illustrates the Yarkovsky effect, a physical phenomenon where the sun intensely heats the day side of a rotating asteroid. Because the asteroid turns, its surface experiences a constant cycle of extreme heating and cooling. As the hot side rotates away from the sun, the surface cools down by emitting thermal photons. Those photons possess tiny amounts of momentum, acting like a weak thruster that slowly but continuously pushes the asteroid off its originally predicted path. We can't accurately calculate exactly how much the Yarkovsky effect will nudge a specific asteroid because we don't know the exact makeup of its surface. To know where a rock is going, we have to go out and physically touch it. On Friday, April 13, 2029, Apophis will safely graze past our planet, missing us by only about 20,000 miles. NASA is using that close approach as an opportunity. They've redirected a spacecraft, now named OSIRIS-APEX, to intercept Apophis right as it zips past Earth. Instead of observing from a distance, the spacecraft will perform an aggressive landing maneuver, firing its thrusters directly downward to violently blast away the thick outer crust of dust and expose the material underneath. After that, OSIRIS-APEX will spend 18 months anchored near the asteroid. It will continuously map the rock's structural shape and monitor every microscopic shift in its trajectory. By measuring exactly how the rock absorbs and radiates heat, scientists can finally crack the math of the Yarkovsky effect. What started as a terrifying unknown becomes the exact data we need to build a reliable planetary defense system. Once we know an asteroid's precise composition and path, we can actually do something about it. Engineers have proposed several deflection tactics, from anchoring chemical rockets to the surface to detonating charges inside the rock. We can also rely on kinetic impact. By slamming a heavy, high-speed probe directly into the side of the asteroid, we can permanently alter its momentum and steer it safely away from Earth. These celestial bodies function as pristine time capsules, preserved in the vacuum of space for billions of years. Because they haven't undergone the erosion we see on Earth, their chemical makeup remains untouched. Analyzing this ancient material could finally confirm long-standing theories about our own origins. We might find the exact chemical signatures showing how water and potentially the very first building blocks of life were delivered to Earth on the backs of asteroids. Successfully reaching Apophis secures our future, while simultaneously offering us a window into the earliest moments of the solar system. There is also a massive economic incentive. Apophis is an S-type asteroid, which is a classification for space rocks composed heavily of silicate materials and pure metals. Instead of the oxidized ores we mine on Earth, these rocks contain immense, untouched deposits of iron, nickel, and highly valuable elements like platinum. A single asteroid of this size could theoretically hold quadrillions of dollars worth of precious metals. As launch technologies improve and space travel gets cheaper, tracking these objects lays the groundwork for an extremely profitable space mining industry. While the idea of 40,000 massive rocks flying around our cosmic neighborhood sounds terrifying, remember that NASA's automated systems are watching them constantly. For the vast majority, the calculated odds of an actual impact are well under 1%. When Apophis makes its historic flyby in 2029, humanity won't be looking up in panic. We'll be looking at a target, ready to collect the data, the science, and potentially the resources that will push our species further out into the solar system.